And how many you guys are Moab Data Club? 1 and 2. The shirt's in the back. The photo pass is in the back. So you had to be in the club. Moab Data. Yep. They have different sizes inside too. So you gotta look up the sizes. Okay, so what we're gonna do is we're gonna go talk about rational functions. The rational function is start with y equal to 1 over x. This is the graph. Do you guys remember what 1 over x graph look like? Huh? Yeah. So it's gonna be like this, and the graph's gonna be like this. This is 1 over x graph. Now, the two things that you need to know, there is a asymptote at here. It's called vertical asymptote, and this is a horizontal asymptote. So the translating is based on this point. That point where the two horizontal intercept, you can move left and right, up and down. Depends on how they move. Okay, so this is a 1 over x graph. So we know how to do this. On the last test, I put in says, hey, do you know how to graph that says negative 1 over x plus 2 minus 5 minus 4? I say, hey, can you graph this? Do you know how to graph this function? Yes? Good. So start by graphing that function for me and make sure that you guys all on the same track. And once you do that, check with another person, says, hey, how is their graph? But if you finish, check another person next to you, see how they graphing the same thing.
See how you like. So this is the middle. You can imagine. So think of moving here to be here. So there would be like things would be like 1 point. It's going. Well, for now, it's kind of like that too.
Yeah.
You go from like the dot, right? Then go 1 1.
Yeah, the dot where the horizontal asymptote and vertical asymptote, you translate that.
Okay.
You translate asymptote and then graphs just accordingly. But since this one's a negative 1 on the top, so you have some type of reflection. they change a quadrant. They change like instead of first and third, you'll be second and fourth. Okay, did everybody graph it? Diego, did you graph it?
Yeah.
Yeah?
You want to-
No. I trust you.
Hey, Sherman, I want to like throw my foot.
Diego is like one of my favorite person to go to. He's a funny guy.
Yeah.
So what I'm gonna do is I'm gonna take this. Now, do you realize at this point where this point here is the one that is moving left and right? So in this case, +2 is moving where? Left 2, right? So 1, 2, and move down 4. 1, 2, 3, 4. So that's the point where the point of the asymptote is creating. So then it's gonna be like this. You're gonna draw a dotted line here, and you're gonna draw a dotted line here. Now the problem is this one's a negative sign, so instead this is a 1, so this is a -1, so they just reflect toward this particular point. So instead of be first and fourth quadrant, it's gonna be second. So the graph's gonna be like this, and this is gonna be like this. Does that make sense for everybody? And we can check it out on the actual graph. Let's just say if today we have a -1 all over x, was it +2? -4, right? And x equal to -2. And if you click, by the way, you guys can learn how to do this too. You click on the red button long enough, the thing will show up with color adjustments, so you can change the color. So try it. And then you can click on a dotted line here, and that's your asymptote. And also y is equal to -4. That's, if you click long enough, they will show up the dotted line. So that's your asymptote on both lines. So that's exactly what the graph is doing. Okay, so you can get your phone out and try to graph it, because the more you know how to use Desmos, the better off that you're gonna do well on your SAT, because the more things that you can work with, more leverage, more tools. And PSAT also, you can use Desmos now, so you can use Desmos pretty much on a lot of things. So this is a very good way to understand how to draw an asymptote. An asymptote is a line that you never touch. Never ever touch. So now horizontal asymptote is a little bit different. Horizontal asymptote, you can actually touch them. They actually go through in the middle part. They can go through, and it will come back to the asymptote. They will come toward the asymptote. So a lot of people thought like asymptote you cannot touch, but horizontal is a little bit different. Horizontal is a little bit different. Vertical is the one that you never touch. Horizontal are different, because the definition of that is a little bit different. Is this okay? Okay, so let's start by talking about what is a rational function. This is also known as a reciprocal function. Now, reciprocal function is a R functions. An R function, that means the symmetry to origin. It's symmetry to origin. It has a horizontal asymptote. It has a vertical asymptote. At horizontal asymptote is y equal to 0, x equal to 0. So they are function. And you can translate that. However, there's some new notation now. So I'm gonna write in red. There's a new notation that you never seen before. It's gonna be limits. As x approach, now instead of approaching infinity and negative infinity, we are approaching a value. 0. from the left side. Okay, I'm gonna say that again. 0 from the left side. That means limit x approach 0 from the left side. And you can reach any number from the left side or right side. In this case, we're choosing 0. And you can also reach x approach 0 from, so all this stuff is all for this graph. So limit x approach positive side of f of x. So I will write down what does that mean. Approaching 0 from left side. This one's approaching 0 from the right side. And that's why you have this, the positive exponents, they're not exponent. This means positive from the right side. Now, how do I approach 0 from the left side? Guys, pay attention. How does 0 approach from the left side? If I go from the left side like this, what's that eventually goes to? Negative infinity. So this was equal to negative infinity. Does that make sense? Because if you go from the 0 from the left, so you look at the left side of that 0, the graph's going to go down to a vertical asymptote. That's going to be negative infinity. Is that okay? What happens 0 approach 0, x approaches 0 from the positive side? Positive infinity. Now, can you write 1 for here? What do you think I want to limit x approach? Especially on which one? Vertical asymptote, and specifically. So what do I approach? Limits. That's an x approach what? -2. And we start from the left side. Is that okay? Negatives. That means the left side. Is that okay? What is that equal to? Positive infinity. That's good, because if you approach, this is a -2 from the left side, then it's going to go like this. And also limit x approach to positive infinity. No, it's reached -2 from the positives. What is that equal to? Negative infinity, because it's going down. Does that make sense? So you can approach a value from the left or right. Look at the graph. How does a graph going from the left, and how does the graph going to the right? Emily, you understand? Kind of looking down. So when you're looking down, I'm gonna say, hey, do you really understand? Or are you looking at the graph? Okay. And if I ever look at a graph, then pretty much approaching -2 from the left side, it's going to be like this point. See, this just keep on going up. But approaching -2 from the right side, it's going to go, according to this graph, it's going to go down. Negative infinity. Is this confusing? Okay, good. So we got through a little bit of harder part. We also talk about what happened when 1 over x squared. What do you think the graph of 1 over x graph look like? 1 over x squared graph look like? Jocelyn, do you know what 1 over x squared graph look like? Yes. Okay. Kelly says it looked like kind of like volcano, because it still have x equal to 0. It's gonna be an asymptote. There's still asymptote here, because you technically cannot plug in 0, just like this one. The vertical asymptote is x cannot equal to 0, because when x equal to 0, it's gonna be 1 over 0 is undefined. So anything on denominator is undefined, that's gonna be 0. Same thing on this one, is gonna be 0. So there's an asymptote right here. But except it doesn't matter what number you plug in. If you plug in negative value, a positive number, it's gonna all go this way. And this is all gonna go this way. And there's an asymptote here. So there's two type of asymptote. Vertical and horizontal. Is that okay? How do I find vertical asymptote, guys? Do you know? How do I find vertical asymptote? Is a set denominator equal to 0. So in this case, x squared equal to 0, x equal to 0. So x equal to 0 is a vertical asymptote. Is that okay? And you just solve for it. Now, how do I find domain? Domain is the same exact thing. You said denominator cannot equal to 0, because when that denominator equal to 0, well, cannot equal to 0 is undefined, right? So x cannot equal to 0. So therefore, domain is going to be negative infinity to 0, union from 0 to infinity. Because you can equal to any other value except 0. And that's the way I write interval notation. So this is domain. You set the denominator, you solve for it. Am I going too fast? Jocelyn, are you okay? Do you understand? If you don't understand, just let me know, because I'd rather you ask me now than later. If later, then you ask me, I'll be like, I don't know. Now you ask me, I'll be like, I'll answer your question. It doesn't matter how bad the question is. Some people are afraid to ask questions. The question is how you learn. Set denominator equal to 0. Why?
Yeah.
Because when denominator equal to 0, you got a number divided by 0. A number over 0 is undefined, not definable. But think about it. If I were to plug in something that says, let's just say 1 over x, right? Let's just plug in that says, you plug in approaching 0 from the left side. Because we know we plug in 0 is undefined. Does that make sense? What happens if you plug in 0.1? Well, 1 over 0.1 is what? What is 1? No, don't use calculator. What the hell?
I don't like decimals.
What kind of Asian are you? 1 divided by 0.1. Come on. 1 divided by 0.1. It's not that hard. No. 10. Oh, it's okay. I'm gonna show you. 0.1 is 1 over 10, right? So 1 divided 1 over 10 is what? Well, that means 1 divided by 1 over 10. That means 1 times 10 over 1. So that's equal to 10. Does that make sense?
Yeah.
What happens if we plug in something that says 0.01? Good. And that's why this value is gonna go. It's gonna go to 100. If very, very close, it's gonna go 100. But it's not gonna touch the 0. Right? Does that make sense?
Mm-hmm.
Because you're gonna go so close to it, but you're not gonna touch them. You can even go in closer, 0.001, so that's be 1,000. So you go to up to 1,000 at 0.01, but not touching the y-axis. That's all asymptote is you cannot reach them. You cannot touch them at all. Is that okay? Okay. Let's talk about something else. Well, let's give you a question. Ask you, hey, if you can find the domain and vertical asymptote. So domain is right out this way because this negative infinity to 0, but this open parenthesis because you cannot equal to 0. And then 0 to infinity. That's another way to write domain. Some of you guys write domain says all real number in the past, except x cannot equal to 0, but this is a much more preferable. This is going to be domain. So imagine this. What is domain of this one? And what is the vertical asymptote of this one? And yes, you can have more than one vertical asymptote. You can have infinite amount of vertical asymptote. You can have So all I care is depend on the question. If you look at tangent graph, you have infinite amount of asymptote. Can you tell me where the vertical asymptote is, and can you tell me the domain? How many of you guys have found domain already? Only one? Yeah, wait a little bit more. How many of you guys found domain already? Okay, now it's a little bit more. How many of you guys find vertical asymptote already? Okay, actually more. Okay, let's ask Larissa. It's okay.
Minus.
You got this. Can you either tell me which one you prefer, domain or vertical asymptote? You don't, but can you tell me about vertical asymptote?
Square root. What's square root? So it's 2 vertical.
Perfect. Except you're missing something. You did very good, by the way. So denominator, you said denominator equal to 0, right? Set denominator equal to 0. So this is how do you find v dot a, which is vertical asymptote. So be x squared minus 4 can equal to 0. There's 2 ways to do it. You can factor it, and it's x equal to -2, x equal to 2. Please write down x equal to 2, x equal to -2. Yesterday I gave you a calculus test, and I told them find x-intercept. And what they did is they find x-intercept. They say 3. I'm like, what the hell is 3? 3 is not x-intercept. And then some student write down x equal to 3. I'm like, x equal to 3? No, that's the wrong answer. It's 3, comma 0. That's a coordinate. 3, if you say x equal to 3, it's a straight line. You cannot say x-intercept x equal to 3. No, it's 3, comma 0. Okay? On your test, on my calculus test, I mark everybody off. Everybody's complaining. I says, I don't care. If you type in the decimal, you type in x equal to 3, are they going to come out a coordinate or a dot? Right? So you have to tell me the right information. So in this case, you cannot just tell me plus minus 2. The only problem that Larissa did is she did not tell me x equal to those values. Because x equal to 2 and x equal to -2, that's your vertical asymptote. So you can say x equal to 2 and x equal to -2. Now you're going to say, hey, how do I find domain? Domain's very easy. It's you do the same thing, but you cannot 0 equal to 0. Because if they equal to 0, is a denominator equal to 0 is undefined, right? So be x plus 2 and x minus 2 cannot equal to 0. So x plus 2 cannot equal to 0. X cannot equal to -2. X minus 2 equal to 0. X cannot equal to 2. Then you say, oh, okay, well, x cannot equal to -2. What does that mean? That means there was a number line at -2 and +2. And that's going to be open circle. Anything between that is fine. Or -infinity to -2. Union from -2 to 2. Union from 2 to infinity. Is that okay? That's how you find domain. That's the interval notation. You follow me so far? Okay, now that's how you find domain. Now, what we're gonna talk about is next thing. Next thing is, how do you find something called removable discontinuity? Today we learned a new word. It's called removable discontinuity. I think how to spell continuity. Is that right? Continuity? Okay, removable discontinuity. In another word, in human language, that not a fancy word is also known as something else. Hold on, let me get to that in a second. So I'm gonna give you a graph. I'm gonna say it's x squared minus 4 over x minus 2. I'm gonna ask you, what do you think this graph look like? Can you tell me what this graph look like? X squared minus 4 over x minus 2. Like, without looking on decimals, what do you think this graph will look like? X squared minus 4 over x minus 2. Raise your hand if you think you know. Don't worry about it. If you guess right, you told me wrong answer. I never teach you, so it's okay. Okay, Winston, what do you think it look like?
It's like two parabolas, but there's like two.
Okay, two parabola with the asymptote at 2. Anybody else? I'm not saying right or wrong on anybody. Even you get it wrong, don't feel embarrassed, don't feel bad, don't feel anything. Yes, Amelia?
Could it be, because you can factor it out to make it x plus 2, could it be just a linear function and it's like a line
Okay.
just going through?
Anybody else? Possibly. Anybody else? No one? How many people agree with Winston? How many people agree with Amelia? There was a few. Okay. That's okay. Hey, at least he had balls to tell me what do you think the answer is. Sometimes you just have to say, this is what I think. It's okay to be wrong because I haven't teach you yet. Okay, so let's show you the graph what let's look like, right? Is x plus 2 or x minus 2? It looks like a straight line. Then you say, wait, is there anything special about this straight line? Do you know anything else about this line? There's something else happen on this line that you don't see. Yes?
Isn't there like a disruption like one point where it's like inclined?
Okay, where do they look at? Where do they look at?
Maybe like positive 2, like on the y plus.
Okay,
I don't know.
I don't know. Let's go see. You say where?
Oh, that's wrong.
At here, you mean?
Yeah.
It looks okay. Where at? She's not wrong though.
2 comes here.
2 comma 0? 2 comma what? 2 comma 4? Okay, let's go look. I passed it. Okay, there is a hole. So, how do you find out this hole? Now, remember, I will ask you a coordinate of this hole. So then what she says, well, f of x equal to x squared minus 4. That's equal to x plus 2 and x minus 2 because she says I'm very good at factoring now. And you can simplify here. That's equal to x plus 2. Now, but this x plus 2 is a new function. They kind of have something happen right before, because if you ask domain here, right? Domain is going to be negative infinity to 2 and then 2 to infinity. 2 to infinity. Right? Because x cannot equal to 2. Then you say this is still x cannot equal to 2. Because when x equal to 2, you're going to plug in here before you plug in here. You're going to get something over 0. Then you're like, wait. Now, whatever this is, we know that x equal to 2, but this is also known as hole. So write it down this. Cancel factor is the location, the x location of a hole, or also known as a removable discontinuity. Okay, so the cancel factor, anytime you see a cancel factor, boom, x minus 2. And what you're going to do is, how do you find it? You set x cancel factor equal to 0. So x equal to 2. We know it occurred at 2. Yes. Give me a second. Give me 1 second. Let me finish this one. We know it occurred at x equal to 2. But what is the y value? Well, the 2 can plug into the new function. So plug in into the new function. You can find the hole, find the location of the hole. So the new function is f of x equal to x plus 2, but x cannot equal to 2. But you can plug in 2 here though. 2 plus 2 is equal to 4. So if I plug in 2, it's 4. So be 2 comma 4 is the hole, which is removable discontinuity. Removable discontinuity. How many of you guys lost? Yes.
It's been like a 4 again.
Yes. I know it happened at 2. I said the cancel factor equal to 0. Does that make sense?
Mhm.
I got 2, right? Now what happened to 2? I'm going to plug in the new equation. Because I find out a coordinate. That's a new equation. If I want to find out a coordinate of a new equation, I'm going to plug in the 2 into the new equation. I cannot plug in the old equation because I'm going to get indefined. Or it's actually known as an indeterminate. But that's removable discontinuity. So the hole is also known as this. Is at 2 comma 4 and remove discontinuity. You got it? Okay. Let me ask you how to graph something. You guys ready? Oh, by the way, the x plus 2 is going to be like this, right? X plus 2 is just y-intercept is at 2. Y-intercept at 2, and it's going to go up by 1. Except this one is going to be open circle. And it's going to be like this. So that's end up to be a straight line. Here's the thing. I want you to graph this one. Remember, we're graphing a new function. We're not graphing the old function. We're graphing the new function, okay? So this one I want you to ask you to graph. New function may or may not be aligned. Maybe something that you know how to graph. You finish card? Can't see over. Yeah, but there was something else on the graph that you did not find. So obviously this is a graph. Now we don't know what a graph look like, but maybe we can make it look simpler. How can I look simpler? Huh? Factoring, because the bottom is a trinomial, probably something to do with factoring, right? So what I'm gonna do is I'm gonna factor this, and that's gonna be x minus 3. What's a factor on the bottom? X minus 3 and x plus 2. Is that okay? And a lot of you guys cancel, but when you cancel, please get a habit, write down 1 next to it. Otherwise, you think the function is x plus 2. I don't know if anybody did that just now. But you have to write down 1 there, so you know it's 1 over x plus 2. Now we say, Winston says, I know how to graph this. This is just a reciprocal graph going left. But there was a little bit more to that. Because there is a graph, yes, there are a graph like this. And it's going to go 2 units to the left. And that's going to create an asymptote right here. You're not wrong. And the graph's going to be something like this and this. And you're like, oh, okay, well, there's got to be more. What is more? Remember the cancel factor, right? You set the cancel factor equal to what? And you solve for it. Is that okay? And plug it 3 back into here. So it'll be f of 3 is equal to 1 over 3 plus 2. So it'll be 3 comma 1 over 5. That is a whole. Does that make sense? Or also known as removal discontinuity. So at 3 and 1 over 5. So at 3 and 1 over 5 is right here. This is the 1. 1 over 5 is 0.2. So 1 over 5 is right here. Besides, we should know the graph's gonna be like this. And this is another part of the graph. And do you understand? So you graph this function. You always graph the new function. But it may not be done because you have a cancel factor. If you have a cancel factor, you gotta find the coordinate of this hole. Find out, set the cancel factor equal to 0 first, and take that 0, take that, plug into the new function. You'll find out the y value. If you don't believe me, let's try it. X minus 3 over what? X squared minus x minus 6. So if you look at this, it looks like normal this. But remember, there was something else happened. Look at this. Look at what happened when they go to 3. Do you see that? There was a hole at, well, we don't know what a y value, but we know it's very close to 0.2. So y equal to 0.2, it should intersect. So it should intersect that hole. But then you don't need to worry about it. You're going to say reward discontinuity happened at 3, -5. Vertical asymptote is set. New denominator, not the old denominator. Because the old denominator has 3 and -2, right? You thought it was true vertical asymptote. There was a not. Set the new denominator equal to 0. So before we did not write that. Set new denominator equal to 0. In this case, it's x plus 2 equal to 0. X equal to -2. And there's asymptote right here. And that's how you graph this. Is that okay? Now let's talk about horizontal asymptote. So horizontal asymptote is actually very easy to determine. You compare the degree. So horizontal asymptote you might want to write this. You compare the highest degree. Compare the highest degree of the rational function of the numerator and denominator of numerator and denominator of rational function and let's just say if I have 3x squared plus 4 over 6x squared plus x plus 1. In this case, do they have the same degree? The highest degree is the same, right? If they are the same, so it's same degree, then you look at the coefficient. So in this case, it's 3 over 6, which is equal to 1/2. You're just going to take this 3 over 6, and that's equal to 1/2. So that means y is equal to 1/2 is your horizontal asymptote. Does that make sense? What if you have 2x squared plus 3x over 10x squared minus 5x plus 1? What is the horizontal asymptote here? What is it? 1/5. Does that make sense? It would be 2 over 10 because they're the same degree. Now, what if the numerator degree is lesser than denominator? So let's say 2x over 3x squared plus 4. This one, horizontal asymptote, is always 0. If numerator degree is less than denominator, then there will be 0 all the time. All the time, always 0. Yeah. Now, if one more thing, if this numerator's degree is larger, then there'll be no horizontal asymptote. That's it. We're done. Sorry. So if you have denominator is larger, this horizontal asymptote is going to be 0. You can graph it. You can see it. Today's homework, you got to check it.
Wait, if the horizontal is the numerator is over the denominator, that means it's none?
Numerator is greater than denominator is none.
None?
Yeah. So if a numerator is greater than denominator, then that's none. There's no horizontal asymptote.
Then you said like
If it's equal to, just compare the coefficients.
the above is less than below, then it's gonna be 0, and if the one above is 1 is 3, and below is yeah.
Oh, I gotta turn off stream. Yeah. Last time was 72. I forgot to turn off for 2 days.